Morning all of you. Myself Reena Jarwal from Shri Digambar Institute of Technology, Dausa. Today I discuss about the topic of time response. Let us start. First of all, what is time response? So generally, the time response of a system means how a system behaves in accordance with time. So generally, when we apply the input on a system, it produces some output, and when this output is varies accordance with time is known as time response. Generally, the time is an independent variable. Next, there is two types of time response, that is transient response and steady state response. In transient response, the response that goes from the initial state to the final state means generally the response that is varies continuously with time is known as transient response, and the response that fixed and never continuously travel with time is known as steady state response, means the state with fixed response when time reaches infinity. That means this, for example, if the transient response is this, then steady state response is represented as this, means a fixed time. Now the time response for transient response, it does not depends on input signal, but for steady state response it depends on the input signal. Generally, in transient response it reveals the nature of response, and for steady state response it reveals the accuracy of the control system. This reveals the accuracy and this reveals the nature. So these are the parameters for time response. So first parameter is that total response. Generally, the total response of system is addition of transient response and steady state response, means the total response is always equals to transient response plus steady state response. Generally, it is total response is denoted by C of T. Next, second parameter, that is steady state error. The difference between the desired and output and actual output of the system is known as steady state. So difference means desired output minus actual output is always gives the steady state error. Next, analysis of first order control system. So in time response of a first order control system, we define a system that is, for example, this. If we apply RS on this, there will be a system that is 1 upon ST, and this is feedback to input. This is an error detector. So here 1 upon S2 is represented as system, RS is represented as input, and C of S is represented as output. So in feedback system we represented it as CS of RS is equals to 1 upon S2 plus 1. Now the RS is shifted here, so C of S is equals to 1 upon 2S plus 1 R of S. For unit step function, R of S is always equals to 1 upon S. How? Because R of T is always equals to 1 for unit step signal, so the Laplace transform of R of T is equals to 1 upon S. So put the value of R of S in this, so it is represented as this vector. Next, now the factor is taking inverse Laplace transform, so the step response is represented and produced as C of T is equals to 1 minus e raised to power minus t upon 2. The time constant is, if t is equals to tau, then the step response is always equals to C of tau is equals to 0.63, where tau is referred to as time constant of the response. So next, time response of a second order control system. In second order control system, we see that here a diagram of second control system is present, where R of S is worked as input, C of S is worked as output, and omega n square upon S, open bracket, S plus 2 del omega n close bracket, is known as system. So applying the feedback, so by solve out that, after that we produced this R of S is equals to omega n square upon S square plus 2 del omega ns plus omega n square, where omega n is natural frequency, del is damping ratio, and del omega n is damping factor. So calculate one by one for input test signals. So first of all, time response analysis when input is unit step function. So RT is equals to 1 and R of S is equals to 1 upon S, represented here. So C of S is equals to 1 upon S omega n square plus 2 del omega ns plus omega n square. So C of S, taking partial fraction of this, after taking partial fraction, A, B and C produced as this. So put the value of A, B, C. So after that C of S output equation is generated as this. So C of S is equals to 1 upon S minus S plus del omega n upon S plus del omega n whole square plus omega square minus del omega n omega d by omega d S plus del omega n whole square plus omega d square. This is the output equation of C of S. Now taking the inverse Laplace transform on both sides, so we get C of t is equals to 1 minus e raised to power minus del omega n t cos omega dt minus del omega n by omega d e raised to power minus del omega n t sin omega dt. After solving this, the output response is produced as Ct is equals to 1 minus e raised to power minus del omega n t by root 1 minus del square sin omega dt plus phi, where phi is equals to tan inverse root 1 minus del square by del. Now these output is applied as number of system, that is underdamped system, undamped system, underdamped system, critical damped system and overdamped system. In underdamped system, the del means damping ratio is always less than 1. So generally roots are complex and the time response is presented as this. And for undamped system, del is always equals to 0, so roots are imaginary and the time response is represented as this. For critical damped system, del is always equals to 1, so roots are real and same and the time response is represented as this. And for overdamped system, del is always greater than 1, so the roots are real and different. So the time response for overdamped function is this. Generally for oscillations, for means undamped oscillation, underdamped, critical damped, it is provide a different time response. So generally it is only suitable for second order system. Now the question that is generated in our mind is that what is damping ratio? Here del is represented as damping ratio. So generally the actual damping by critical damping is always produce a damping ratio. So generally we can say that the ratio between the actual damping and the critical damping is called damping ratio, and it is always given by the formula, that is del omega n by omega n is equals to del, where del omega n is represented as actual damping and omega n is represented as critical damping. Thank you.